What is up, guys, and welcome back. This is Unit 2 of the semester exam review for 2025. I am super excited. I actually made a mistake on the problem number 1. I forgot my negative sign. So I had to restart the video. We are back again. So I'm putting us on the document camera here. You can see that I've already solved number 1. All right, I'm just going to walk us through the solution. All right, if you have questions, email me. It's not worth redoing. All right, so we're going to do something very similar in the next problem anyways. So what I did, we wanted it says to write an equation in slope-intercept form of a line described. And then it says it has to have the points -3, -9, and -5, -3. So this is the form I was looking for. I began by using this form, which in geometry we said was always better. This is called point slope form. And in geometry, that's the one we like the most. So I immediately started there. I realized I need the slope. So I found the slope, which is given by the rate of change in y divided by the rate of change in x, to give us an overall rate of change. Sorry, that's supposed to be a negative sign there. And what I did here was when I added -5 and 3, I put +2. But really, it's -2, which gives you a slope of -3. All right. Then when I go to write my equation, I just plugged in this up here. This is my next step. I plugged in to this point slope form of the line, giving -9 and -3, which became positive. Then I distributed out this -3, subtracted 9 from both sides to get my final answer in mx plus b form. Beautiful, look at that. So there's slope and intercept, and I'm just going to do this one more time on the next one. It's going to be very, very similar for this. So we want to pass through, it has to be in slope-intercept form. We want this line to pass through the point -8, 5, and be parallel to the line y equals 4x minus 9. So this line is already in y equals mx plus b form. Look at how fast the x is changing. It's changing by 4. Really, this says that y... Yeah, there's a bell to dismiss everyone while I make this in fourth period. No way. Horrible time. I don't even know if you guys can hear it on the microphone. All right? Anyways, if y is equal to 4x, it's showing us that y is changing by a rate of 4 times x. So that is the slope we are after. So here, we'll just keep note of that. We want this line to be parallel, so it has to have the same slope. Don't parallel lines have the same slope? So, for this to work out, we need the y minus y1 equals m times x minus x1, the point slope form, and I'm just going to plug in this point that I have right here. So I get y minus, and then y1 is 5, equals my slope, which we said has to be 4 in order for this line to be parallel, times x minus x1, which is really -8, so this becomes a +8. All right, and now this is in point slope form, but to be in sloped intercept form, you only have to distribute, and then I'll add 5 to both sides. So here, I'm going to come up to this next line. I'm going to distribute the 4 out. I get y minus 5 equals 4 times x is 4x. Already, 4 times 8 is, 32. Almost at 24. It is 32. And then we'll add 5 to both sides to get that y is equal to 4 times x plus 37. Look at that. And ladies and gentlemen, that's all there is to it. This is a good example of, let's see here. This is a good example. Something very similar to the last problem. We got our slope-intercept form. We know we're in slope-intercept form because the y is alone. And we have something times x plus something else. So that's our mx plus b. Very nice. Now we're going to keep going. We're going to state whether these lines are parallel, perpendicular, or neither. And I'm going to say to each other. It doesn't say to parallel to what? Perpendicular to what? So I'm guessing it just wants us to compare these to one another. Here we see that the slope is 4. All right, and that just tells us in the problem y equals 4x. So that's the slope right there. Remember, for parallel lines, we want the same slope. For perpendicular lines, we want the negative reciprocal. And if neither, that's just skewed. Okay? So you may have heard of me called this skewed before. Anyways, so for 4y plus 12 equals 9x. Now, if you were going to put this into y equals mx plus b form, you would have to subtract this 12 over and then divide by 4 to isolate the y. So that means the slope here is going to be 9 divided by 4. Alrighty? So these in relation to each other are neither. They are skewed. But I'll keep going. Here, do you guys see? This is a negative y. If I subtracted, this would be a negative x. Then I would divide both sides by 3. So that also gives you a slope of positive 4, okay? So I'm kind of thinking out loud. I'm imagining turning this in to y equals mx plus b form. I'm just looking at what I would have to do. Here, I'd have to subtract 4x, then divide by 9. So this is negative 4, and then I'm dividing by 9. Look at that. So what I think they want us to say here, you guys can see, 4 and 4, I'm going to say parallel to C, and obviously it's skewed to the others. This one is parallel to A, skewed to the others. And then here for my answer, I'm going to say this guy is perpendicular, and I'm not going to write out perpendicular, but perpendicular to D, part D. This one is perpendicular to part B. And look at that. Isn't that beautiful? So do you guys see this fraction has been flipped over and negated. That's how you know these guys are perpendicular. So I'm just going to make a note of that here. 9/4 is perpendicular to negative 4/9 in the Euclidean grid. All right. So to write an equation of a line that is perpendicular, is the perpendicular bisector of a line segment with endpoints, this and this, I'm going to draw a picture. So -5 and -4, that's my first point. My other point is -7 and 2. All right. Whoa. -7 and 2. So to find the perpendicular bisector, I need to find a line. So this is a line. All right. That is in the middle, that intersects in the middle here, and is perpendicular to this line. So I'm searching for this line that I did in light, that I lightly colored. So to be certain, I know that this line is going to contain this point and be perpendicular to this. So I'm kind of going to do this the same way I did number 2 up here, number 1. All right, very similarly. So what's in the middle here? Let's see. This midpoint M is given by the sum of the x's, -7 plus -5 over 2, right? This is a midpoint formula. I'm taking a video. Uh-oh. All right, we were briefly interrupted. That's okay. They forgot something very important, so we'll allow it. We'll allow it. Anyways, I'm back. So we're going to do, continuing the midpoint formula here, I have the y coordinates. I have 2, and then plus a -4. So essentially what this is doing, the midpoint is it's taking the average of the x values. I'm adding them up and then dividing by how many there are, right? And then it's averaging the y values. I'm adding them up and then dividing by how many there are, right? This way, this middle point will be perfectly weighted between both points. So this equals, and then -7 plus a -5, that's a -12 divided by 2 is -6. All right, and then doesn't that make sense? If you look, isn't -6 in the middle of -5 and -7? Yes, it is, absolutely. So -2 plus, 2 plus -4 is -2 divided by 2 is -1. Sorry guys, I know I'm going fast. I just got a lot to do today, and this video is going to take forever. Oh my gosh, I'm going to cry. Okay, is equal to -6, common -1. So there's the middle. So now I know this point is going to go on my line. That's this point right here. So I now need to make a perpendicular line. Well, to make a perpendicular line, I'm going to first need to know the slope. So this is a capital M, I should say. That's maybe not a good letter choice by me. I'm now going to do lowercase m, the slope, which is equal to y2 minus y1 over x2 minus x1. Just to save me room, I'm not going to write the whole formula out. Okay, I see that the change here is 6 on the top in the y values. Well, I guess I could just say it goes down 6. Alrighty? And then from here to here, it goes up from -7 to -5. It goes up by 2. So this is a slope of -3. Alright? Little cheat code there if you don't want to have to do slope formula every time. Sorry, I just want to make sure I have plenty of room here, so I'm going to change that out. -3. So to make a perpendicular slope, I'm going to flip this guy over so that it's 1/3. And then also make it positive. So this is my perpendicular slope here. That I'm going to use in the equation of my line, and I'm done. I'm now going to use the point slope form equation of a line to write out a line that has exactly this equation. It has a slope of positive 1/3, and it passes through -6 and -1. So I'm going to do y plus 1 is equal to the slope of 1/3 times x minus x1, which is really plus 6. And look at that. This equation, this problem does not specify a particular format for the line, so I'm just going to leave it like this. Alrighty? Y plus 1 is equal to 1/3 x plus 6. Very nice. This line passes through the midpoint of the segment given and is perpendicular in regard to the slope. Beautiful. Right? I'm definitely losing my voice, bro. I'm definitely losing my voice. So, for number four, if the segment OK has endpoints 8, -2, and 4, -4, and the segment RT has the endpoints 4, 1, and 8, -7, prove that OK and RT are perpendicular bisectors of each other. So, perpendicular bisectors of each other. So this means there's two segments, I guess. I'm going to draw them out. We have OK, all right, which is at 8, -2, and 4, -4, all right? And then we have 4, -1, 4, 1, and 8, -7. And this is not what they look like. I'm just kind of drawing them. Here's R and T. And we're saying that this point is the midpoint of each. They're perpendicular bisectors to each other. So this line is split in half, but also this line is split in half. Now, these do not necessarily have to be the same. It's not a square, right? It could be a like rhombus, I guess. What am I trying to say here? Parallelogram here. Ready? So it's like a kite, I guess I would say. It's more like a kite. So to prove that this is true, we're going to have to show a few things. First of all, we need to show that these guys intersect at this point here in the middle, and that it's the middle of both. So if these guys had the same midpoint, that would work out, right? So the midpoint of OK is, and I'm just going to add up 8 and 4, divided by 2, so I'm using midpoint from here, -2 plus -4, over 2. That's equal to, so the first midpoint here, 8 plus 4 is 12, divided by 2 is 6. -2 plus a -4 is -6, divided by 2 is -3. All right? And then I'm also going to do the midpoint of RT. So the same thing goes on here. RT has 4 and 8 as well. And then here, I have 1 and -7. Sorry, I thought I just made a mistake there. My brain was like telling me I made a mistake. Okay, so here we have 4 plus 8 divided by 2. That's also 6. And then sure enough, 1 plus -7 is -6 divided by 2 is -3. So you could say from this math we just showed, this means that the midpoint of OK is the same as the midpoint of RT. And consequently, they must intersect at that point. So this shows that they bisect each other. That part is done. Now I'm going to show that they are actually perpendicular. So to show that this is true, I'm going to find the slope of each. So the little m, the slope of OK, is equal to, and that's the change in y divided by the change in x. So from -4 to -2, I should say, well, from -2 to -4, that is a decrease of 2. From 8 to 4, that is a decrease of 4. So this is a slope of positive 1 over 2. And the slope of RT is equal to, and I'm going to do the same thing here. 4 to 8, that is a change of positive 4. But 1 to -7, that is a decrease of 6. Of 8, excuse me, what am I saying? Of 8, right? I have to go to 0 and then all the way to 7, so that's 8 total. And this is -1/2. Oh my gosh. Did I make a mistake? Did I do my... Oh my god, yes, I'm so sorry. Look at this, guys, I'm crazy. I did my x's and y's reversed. -8 on top, my fault. And 4 on the bottom, my fault, twin. -8 divided by 4 is -2. And sure enough, these guys really are negative reciprocals, right? So since that's true, they really are perpendicular. So I'm going to write, therefore, the slope of OK is perpendicular to the slope of RT. So we've shown they're bisectors. We've shown they're perpendicular. Therefore, OK and RT are perpendicular bisectors of each other. Very nice. Look at that. And there's my little statement. But that's how you know we've proven it. So notice that this is just the work for the problem. All right? The answer for the problem is this, right? That you've actually shown it's true. And anyways, let's keep going because we got a lot to do. If A is 3, 8, what would be the coordinates of A prime after the transformation xy moves to, and this reads like moves to or goes to, transforms to, x plus 6, y minus 5. So in order to know this, we'll just take A at 3, 8 and add 6 to x and take away 5 from this. So let's say we could take the transformation here. I guess you could say it moves to A prime. All right. Which is, and really there should be a little like thing here. A little like foot, right? This moves to x plus 6, that is 9. And then y minus 5, that is 3. So A prime is at 9, 3. So this point moves over and down. All right. Let's turn the page. And here we go, some more transformations. Number 6. If G is 3, 4, what would be the coordinates of G prime if you've reflected it over the line y equals x? So here is G. The line y equals x, I hope we all know what that looks like, but it looks like this, right? It's the line, y equals 1 times x plus 0. So it has a slope of 1 and an intercept of 0. This is the line y equals x. We love it. This is called the identity. All right? You may have heard it. And the point G is 3 over and 4 up. So it's like over, I haven't really drawn it well. It should be like 3, how do I say this? Like the line y equals x has the point 3, 3, right? 3, 3 goes on this line because, obviously, y and x are the same. Y equals x. So the point 3, 4 would be 3 over, but then 1 more up because it's 4 up, right? So if I want to reflect G over the line y equals x, I want it to end up over here. Ooh, whoa. On the other side of this line. So what should I do? How could I know the new coordinate of G prime? Well, the new one is going to be in line with the x value of this point, which we said was 3, 3. But it's going to be, if it was 1 more this way, now it's 1 more this way. Right? So G prime is at the new location In the x direction, it started at 3, then moved 1 over. And in the y direction, it is 3. So this is the point 4, 3. All right? That's if you don't know the trick. That's what you do. That's how I would reason it out. All right? The trick is, when you reflect over the line y equals x, you flip x and y. You flip the points x and y. All right? This is why, like the inverse of a function, and to remember this, recall like from Algebra 1, the inverse of a function can be reflected over the line y equals x, right? That's what we're saying here. So, anyways, if the point W is at 5, negative 2, what would be the coordinates of k prime after you rotated counterclockwise 270 degrees? So, here are my axes. I'm going to draw this every time. This helps me so much. All right? Now, 5, negative 2, that's 5 over, right? And then 2 down. There's W right here. 5 over and 2 down. So I'm going to rotate this whole grid around the origin by 270 degrees counterclockwise. Counterclockwise is against the clock. That is, why does it always, it's always so hard for me to think of this. I don't know why. That is this way. Alrighty? In mathematics, that is a positive rotation of 270 degrees. Alrighty? Counterclockwise in mathematics is positive. So I'm not going to overthink this. I'm not going to memorize the rules of rotating to a new quadrant or whatever. I'm just going to look. All right? If each of these sections is 90 degrees, then to go 270 degrees this way, I have to step 1 over, 2 over, that's 90, that's 180, and then one more is, and that's poorly drawn. It should be like more, it should be like down here somewhere. That was my bad. Alrighty? It doesn't really matter though, as long as you know which quadrant it ends up in. So we know that W is going to rotate into this quadrant, then this one, quadrant 3. This is, excuse me, what am I saying? 270 degrees counterclockwise. So this new point, W prime, is in the third quadrant. So notice both of its points, both x and y will be negative because it's to the left and down of the origin. So notice, if it used to be 5 over, now that it's been rotated, it's 5 down. It used to be 2 down, but now that it's been rotated, it's now 2 over. Alrighty? So this new point, W prime, is at the point negative 2, comma, negative 5. 2 to the left and 5 down. Alright? So, what you do here, if you want to rotate 270 degrees counterclockwise, essentially you flip the x and y's. So I guess you could say xy maps to, and this would be y negative x. Very nice. Very, very nice. If you just want to memorize a rule. But this only works for 270 degrees. You got to learn a new one for 180, 90, and the other ones. All right. If k is at 2, negative 2, what would be the coordinates of k prime if you dilated by 1/2 about the origin? So, here's my picture. Over here, I have a point at 2, negative 2. Oh, that's down here. My fault. There's k. And I'm dilating towards the origin. So here's the origin. This dot, this point, is going to travel towards the origin halfway back. So it's going to be here. Well, halfway back from 2, negative 2 is 1, negative 1. All right? And the rule here is xy gets moved to the factor k times x, k times y. Alrighty? So I just multiplied 1/2 by 2, 1/2 times negative 1 to get my answer here. I don't know why this maps to symbol comes out so bad over here. The paper's like curled up, so I can't trust my hand as much on that side. Alrighty, well, two more, baby. And then you guys can do the next one, baby. Yeah. Alrighty. So, sorry guys, I got an important text. My fault. Okay, so we're finishing this off here. What would be the coordinates of k double prime after a reflection about the y-axis? So they're saying take k prime. K double prime literally means k prime. And then prime it again. Move it again. So I'm taking k prime and moving it again. I'm flipping it now over the y-axis. So that means if I'm flipping over the y-axis, then x is going to change. So I'm going to redraw this just to have it clearly. Here's my new point, 1, negative 1. That's k prime. And it's going to flip over the y-axis over here. So this new point is negative 1. Negative 1. So you flip the x values. If you want to go over the y-axis, then the y's stay the same. So you got to flip the x values. So what we'll say here is k double prime, of course, is equal to the new point, negative 1, negative 1. The rule for flipping over the y-axis is xy maps to negative xy. Alrighty? The y, if you're flipping over the y-axis, then the y stays the same. The x is what's changing. All right? So we'll turn the page. Whoa, not turn the page. We're almost done. Number 9. Find the point D, which is 2/3 of the distance from A to B. If A is to negative 2, 5, and B is 10, negative 4. So to find the point D, that's 2/3 from here to here. This is one of my favorite problems. This tests. But the reason why I like this problem is because the formula sucks. So we don't teach it. That means you're on your own. You have to lock in and think about this problem and draw a picture and do actual math. You cannot just sit here and memorize a formula and pass my test anymore. All right, it's about locking in geometry. That's why geometry is so fun for me. So find the point D, which is 2/3 of the distance from A to B. If A is negative 2, 5, and B is 10, negative 4. So to do this, I'm going to draw a picture. All right, the point A is at negative 2, 5. So that's to the left and up. All righty. There's A at negative 2, 5. And the other one is at 10, negative 4. So 10 is over here and then down. So there's 10, negative 4. I want to go 2/3 from A to B. So if I take this line and cut it into thirds, I'm trying to end up here. This is my new point. I'm looking to get 2/3 down the line. So what I'll do is instead, and now that we've had this unit, you can think of this like similar triangles, all right? I'm going to go in the x direction and y direction. So how far do I have to go from negative 2 to 10? That's 12, right? 10 minus a negative 2 is 12. And then here, in the y direction, I'm going from minus 4 to 5. So that is 9 total. So I'm going 9 down, all right? But isn't that, I need to be cutting it into thirds, right? So I'm going to take these. There's my thirds. All right. So what's 1/3 of 9? I'm going to say that's 3, right? But I want 2 of those. So 2 times 3 is 6. So from A, I'm moving down by 6. So this, I guess I'm going to start out by saying this is for the y's. All right. So I'm starting at 5, and then I'm moving down negative by 6, which is negative 1. So my new point has a y coordinate of negative 1. My other one has an x coordinate of, let's see, I need 2, I'm going to do this a slightly different way, 2/3 of 12, which is equal to, in this case, 8, right? 1/3 of 12 is 4. 2 of those is 8, all right? And I'm moving up in the x direction, to the right in the x direction, that's positive, down in the y direction. That's why we chose negative here. So now, starting at A, which has an x-coordinate of -2, I'm going to add my distance of 8. I'm moving over 2/3 of 12, which is, in this case, am I crazy? 6. No, that's correct. All right. -1, 6, a -1. So my new coordinate, xy, is 6, -1. Alrighty? What I'm doing here is I'm literally saying 2, move to the right, 2/3 of 12, which was the change in the x direction. That's how I got that point. All right. And the same thing for y. I just did it I did it in different steps. All right. Anyways, that is beautiful, guys. 30 minutes right there for that video. We got the next one coming up.